Yes. Hey. Mentally math!
Let's get mental!
Alright.
Yeah. You've been having a lot of coffee lately. You're very energetic.
Okay, great. Alright. Gonna give it a couple minutes to let you get out ahead of me.
Thank you.
We know the drill. Moving forward, I have old videos of these lessons already recorded, so I'll probably just put them up. This might be the last one we're recording this year. Oh, it's okay.
Goodbye, YouTube.
Yeah. We'll see, though. We'll see. I mean, these are probably better than those. For one thing, those are just me by myself just explaining it. No class. Those videos have no class. Yeah.
But then who said let's get mental?
Yeah, no, it's just me just doing it, talking about what I'm doing.
Did you say let's get?
No.
Well, did you start
No, but I start every one of greetings, young mathematicians. That's how I start those videos, yeah.
When did you start saying let's get mental?
This year.
Yeah.
We invented it.
Oh, yeah, we did.
Wait, who invented it?
Us.
Yeah.
Because we're so smart. We're mini Einsteins.
Okay, so you're well along here, I will assume.
Definitely.
Okay. So, multiplying these, and it's a negative and a positive, and counting by 15s, 15, 30, 45, 60, 75. Now, this is meant to be an individual exercise. It's not really a group exercise to do together with your friend. And this would be 3 times 10 to the power of 9. Then this be 36 divided by 3 is 12. And then this is similar to yesterday's calculate, where so we're just taking the 2%, multiplying it by 7, so $14. Just add one more dollar for the 0.5%, gets me $15. This one's just multiplying by 10 millimeters to a centimeter. So just bring the decimal over by 1. Boinky. Then, looks like our units here are 50 cents. 50 times 5, 250, or $2.50. Like I said, there shouldn't really be a lot of discussion going on in the room about this. Alright, then, when we're looking at geometric shape, its mirror image would be called a
Reflection.
Very nice.
Why do like 5 people say that?
Actually, you're way better than this morning. It was like I do that, and raise my arms and expect everyone to do it. It was like one guy in the back, and then like one other person like mumbling it. It was so sad. It was just like, it was like, oh.
Sad.
It was devastating. Yes, a little more interject. Okay, I mean they might not realize what I was trying to do. Okay, so this be 500 times 2 is 1,000. Add the half for 250. Give me 1,250 miles. Okay, and today we are talking about multiple unit multipliers.
What?
Oh, okay. Remember, let's not do too much of that. Okay, don't want me, don't know me, and don't say I don't get it. Okay, that's all I ask. Okay, it's okay to ask specific questions though. So these can be a little intimidating. I get it, but it's you just go through the process and it comes out the other side and it works. And, many different math programs follow this exact same method, and as mentioned, it works. So, and I will go through this very slowly. All right, so use 2 unit multipliers to convert 5 hours to seconds. So it's saying how many seconds are in 5 hours. So this is kind of a 2-part thing because we need to, now there are shortcuts. There are shortcuts, but like I said, we're going through a process, and also, so, if you see this on a test, you can solve it any way you like. If you see this on a test, you need to go through the steps that we're about to do. And so for one thing, we are first going to start with the number of hours that we've got, which will be 5. Then we're going to convert that to minutes. Let's see, I don't think I used that there. And then we're going to convert that to seconds. If you already know how to do this using 2 unit multipliers, then yes, please proceed. You don't need me? Proceed, and then you can kick back while I finish it up. Okay, and then, so remember, for unit multipliers, we treat units as things that you can do cross-canceling goodness with, as though they were numbers. Right? So we're starting out with our 5 hours, and Saxon doesn't do this, but I like to put the always ever-present imaginary /1 underneath it just to keep it straight with our other more ratio-looking things. And then a unit multiplier. Need to put, excuse me. So when we're doing these, now your unit multiplier is kind of like your little conversion machine inside the equation. And so in this case, we're going to say there are 60 minutes in every 1 hour. Now, here's the thing, is we don't want hours when we're done.
Yeah.
We only want seconds. So we're trying to get rid of the hours. So if you're wondering, how do I set this up? A good rule of thumb is to think, which one am I trying to get rid of? And I need to put those so that they're across from each other, that one is on top and one is on the bottom, so that we can cross-cancel them. So this is why it is 60 minutes on top and 1 hour on the bottom, necessarily, because this guy is the guy I'm trying to get rid of, so this one needs to be on the bottom. That's why it's not 1 hour on top and 60 minutes on the bottom. So like I said, every 1 hour is 60 minutes. So we're doing 60 minutes to 1 hour.
I'll try not to get it. I think I'll just remember the steps.
Right. Just go through the steps. And then our second unit conversion is minutes to seconds. And in this case, we are trying to get rid of minutes. So that's what's going to go on the bottom. So for every 1 minute, there's 60 seconds. Okay, so that gets us to where we can begin our cross-canceling goodness. So our hours.
Yeah, there are a lot of steps in this.
Mm-hmm. Well, this is kind of the simple one. So our hours, we can cross-cancel.
I feel like we've had problems like this before.
We have. It's just these are more complicated. And also, I believe that you might have had ones that were sort of like this in your written practice.
Yeah, no,
Okay. And so we can cancel all of that. So the only thing that we're left with now is the 5 the 60, this 60, and the unit of seconds.
Oh, this is so satisfying.
Oh, I'm glad you feel that way. Okay, awesome.
I love
Okay,
this lesson.
yay, excellent. Okay, but we need to keep going. All right, so then 5 times 60 is going to get us to 300, and then 300 times 60, so 3 times 6 is 18, and we've got 3 zeros. I'll stack those up. And I'm sort of lost. I kind of need to cram it in. And the only unit that we're left with is
The seconds.
the seconds.
Canceled out everything else.
Yes.
Oh my god, dude,
That's
that's
so
so.
Okay, and here I'm gonna rewrite this down here since I'm falling off the edge of the earth over there. So that gets us our answer of 18,000 seconds are in 5 hours.
This is awesome.
Oh, great! Oh, I'm really glad you feel this way. Awesome. Okay, thank you. Okay, I'll take it. I'll take the W. All right. We have 5 of these examples, and that's the easiest one. Moving along. So, Diego wants to carpet a 16-foot by 9-foot room that has an area of 144 square feet. However, carpet is only sold by the square yard. So how many square yards of carpet does Diego need? Now, we're gonna think of a couple of things here. So I'm gonna lay out a couple of things here just to jog our memory. So you remember yesterday, like we sort of established that, right? Okay, like so a squared is a times a. Okay, now and not only are we using our units as though they were sort of like their numbers in the equation for cross-canceling goodness, but we are also using our units where if you multiply, say, feet times feet, you get square feet, right?
Yeah.
Well, we're also going to go the other way around and decompose those so that on this one, we can kind of see exactly kind of what we're doing with the cross-canceling. Next, if you're thinking that some of these steps are not necessary, you're correct, and we will do a shortcut on the next example. But for now, we're going to say it like this. Is that I better start way on this end this time. So we've got our... So we're starting out with our 144 square feet. We want to know how many square yards we're going to end up with, right? And now just so that you sort of realize what we're working with here is now remember that if we are talking about square yards and there are 3 feet to a yard, that, well, other than my terrible lines here, like that's what that looks like, right? For feet. That makes sense, right? So every square foot is 9 feet. So this doesn't work out simply to just go, well, why don't you just divide it by 3? It doesn't work. Okay. And then we're gonna say, and now I know this is gonna look a little strange, feet times feet, because that is square feet. We're decomposing that, kind of like we were doing yesterday, and I'm going to give this its imaginary /1. And then we're also going to decompose the square yards. So we're going to make 2 unit multipliers of 1 yard is equivalent to 3 feet, and that's also times 1 yard is equivalent to 3 feet. Because if I take these two, if I just took those two, if nothing else here was going on, if I just took these two and just did 1 yard times 1 yard is 1 square yard, and 3 feet times 3 feet is 9 9 square feet.
So you'd also
Right? So this is equal to this. And so this is our real unit multiplier, but for the sake of cross-canceling goodness, we're going to decompose it. Why do you need it? Well, honestly, when we look at the next example, we will see that we actually didn't really fully need it. but we're just trying to show what we're doing with our...
I don't really understand the whole thing.
Yeah, me neither. I don't really get it at
Oh.
all.
I don't get it.
Okay, I don't understand this.
You don't understand why we're doing this?
Well, yeah, I don't really get why you're doing, like,
Why are we decomposing them?
yeah, and, like, why are you doing
Well,
100?
so that you can, well, when we get to the cross-cancelingness, maybe this will make a little bit more sense. Okay, so now I can look at this, and I can look at this,
Cross cancel them?
and I can cross-cancel those, and I can look at this, and look at this, and I can cross-cancel those, right? And so now with what I've got left over, I can just, it's my 144 times 1 times 1 is just otherwise known as 144. And then yard times yard is
Yard squared.
square yards. Yeah, or yard square, yes. And then 3 times 3 is 9. And then that gets this to where I can do this as a division problem.
I looked. Flip the conversion. Can't you flip the conversion as in 3 feet and 1 yard?
Not being able to cross cancel it, no. That's the reason why this one's on the bottom is that this is on the top and I want to get rid of the feet. I want to have no feet, but I want to have a square yard. Okay. All right.
I get how you're doing it.
Okay.
I get it now.
So I'm gonna finish my division here just to finish this up and then I will take your question. All right. So then so this of course is a division problem. I'm gonna leave the square yards out of it for now if that's okay. And so I'll go 54, 16. So 16 square yards is the equivalent of 144 square feet. So that's how you. Okay, I thought you don't need to do that.
Why
Oh,
don't you include the 16 feet?
the 16 feet?
Yeah.
There is no 16 feet.
Like in the problem.
16 feet by 9 feet.
Oh, that's useless information.
But then, why?
He could just say Diego wants to carpet a room that has an area of 144 square feet and it would be not changed at all. So that is useless information. So yeah, this could that, same problem. So just being discerning with information. Yes.
Okay, so I don't get why you do 144 feet times feet.
Because that's how I get my square feet.
Okay, and
You
then
see, so this is equal to this, right? But I've decomposed it just to make it a little bit more obvious about what I'm doing with the cross-canceling. And actually, the next problem, we sort of take this out and skip this step. If that makes you feel better?
okay.
It's just to kind of demonstrate what we're doing as far as the cross-canceling goes.
And why do you do 1 yard over 3 feet times 1 yard over 3 feet? Like
Because
twice?
well, I was kind of showing that too because that is equivalent to a unit multiplier of 1 square yard is equal to 9 square feet. So this is
equal to that.
equal to that. With this, so this is our real unit multiplier. We've just decomposed it to help with our cross-canceling. But like I said, in the next one, we're kind of taking a couple of these steps out. So it's really, if it seems, as I said, if it seems like we're adding a couple of unnecessary extra steps here, like why are we doing that? The answer is just for clarity, and we're going to take off the training wheels moving forward.
I get what you're doing with the 9 feet, but I don't still get how 16 feet is like useless information.
Because it's already, I mean, they could have given us that and not told us it was 144 square feet and made us figure that out itself. So it's just extra information. Like, we don't necessarily need to know that it's a 6 foot by 9 foot room or a 12 by 12 foot room. Like, it doesn't make any difference what the shape of the room is. They're already telling us how many square feet the room is, and that's our conversion.
16 times 9 is 144.
Huh?
16 times 9 is 144.
So 16 feet by 9 feet room is just
Yeah.
144
Yeah,
feet squared.
yeah, but I mean, it could be a 12 by 12 foot room, and it doesn't change the problem at all. So that's why it's useless information. Is they're telling us the area of the room. If they weren't telling us the area of the room, then we would need that to get the area of the room. So that's what makes it useless information. Is we don't work with those numbers at all in this because they've already told us what they.
Oh wait, I think I'm getting it.
Okay, cool. So yeah, they probably made the problem a little bit more confusing just by putting that in there. Yes.
I don't understand why you divided 144 by 12.
Oh, because when I went and did all of my unit cancellation and then multiplied across, I ended up with this, right? I end up with this guy, and this is a division problem. All ratios or fractions are division problems, right? Like 4 halves is just 4 divided by 2, right? So all things that look like fractions or ratios are all just division problems, and you should know that. So that is why I then divided it. Yes.
But if you're so the 1 yard over 3 feet times 1 yard over 3 feet is equal to 1 yard squared over 9 feet squared, right? But then, never mind.
Did you answer your question?
I was still confused because you could cross cancel it. Then I realized it was feet squared, so there's still 2 feet.
Yeah, well, the fact that we make this problem a little bit more complicated than it needs to be maybe also adds to the chance of, like, looking at it and kind of getting a little bamboozled by something there. So here, let's move to this one, and we can see that we didn't really totally have to do all of that. A masonry contractor. I'll explain this a little bit too. A masonry contractor, so it's like some guy that does concrete for a living, needs to pour a concrete foundation for a block wall. So essentially, imagine this is like a 1 foot tall wall that they're going to start putting bricks on top of, right? And so it is 1 foot deep, 1 foot wide, and 100 feet long. So it's like a really, really, really long rectangular prism.
Oh.
Right? So it's like basically the base for a wall where you put the stuff on top of. Okay. A cement truck will deliver the concrete. How many cubic yards of concrete should the contractor order? And also, one thing here is the pizza paradox is in effect here, where you have to buy it by the cubic yard. So if we get something that's has a fraction in it, we're going to need to round to the next highest amount. That makes sense. We'll see that when we get there. Okay, so fundamentally, what we're doing here is we're starting with 100 cubic feet. Okay. Over here, we're going to want the cubic yards. And so what are we going to do in between there? Well, for starters, we're not going to decompose this. You're welcome. Okay, we're just going to do our unit multipliers. However, we are going to decompose our unit multiplier to multiple unit multipliers.
Mr. Fletcher, I think I got this one, but I have a question.
Mm-hmm.
When you have to do those two last unit multipliers, are they for like the 1 foot wide and the 1 foot deep?
Yeah, we're doing all of our units, so cubic units. But you know, and I'll show you at the end. We kind of don't even really need to completely do this decomposition, but
those last
but you know.
we know that 1 foot deep and 1 foot wide is both going to be times 1, and it's going to really be 100. So we just have to use those unit multipliers because like they were supposed to be.
Okay, so okay, I'm gonna spoilers here. Is we could just do this. Oh, actually, though, we would need to already. I can see why they would want to decompose this because we could just skip the steps and do this, knowing that. Oh, actually, sorry. We could just do. You see, this is why we need to do this. We could just do this straight up.
And then just cross cancel them.
And then just cross cancel it out. But and we could just go like. Da-da! Okay, and skip all that. However, I am teaching Saxon math example, and this is how they present it. And I will assume it is for clarity of what we are doing. So, what? And excuse me while I blow it over here. Okay.
But why do you need 3 in that multiplier?
For each dimension. We're doing cubics, right? So basically yard times yard times yard is cubic yards. Okay, so I'm doing this 3 times.
So instead of doing 100 feet cubed for like one or the other for the previous problem, you did 100 feet times feet times feet.
Yeah. So really we can just track this thing, right? We can go, okay, so I'm going to cross cancel this. 1, 2, 3. Does that make sense? No? Yes?
Yeah,
Basically, I can just take off one of the feet for every exponent I've got up here.
Wait, don't you have to cross out that feet as well?
Yes. Oh, okay, yeah. Oh, yeah, at this point, yes. Yes, I should just get rid of the whole thing. Yeah, good point. Okay, so now that I've got that, I can say, okay, well, 100 times 1 times 1 times 1 is 100.
We're going to end up with the decimal.
Then, yes, so we're going to need to end up rounding that. Then yard times yard times yard is yard to the power of 3, otherwise known as cubic yards. And then 3 times 3 times 3 is 27. Okay, so now you would just need to plug this into a division problem. Yes?
Okay, I don't get why at the very beginning you just said I don't get.
He said it, I don't get, and then he started explaining why he doesn't get it. Please.
I don't really get at the very beginning why we have to do 100 feet cubed.
Because the foundation is 1 foot deep, 1 foot wide, and 100 feet long. So that's basically 1 foot deep times 1 foot wide times 100 feet long, and we need to multiply that out to get that guy.
It's kind of the same reason why he, for one of the other problems, he did 100 feet times feet times feet times feet.
Okay, so spoilers. once you do out this, I'm not going to do the long division. Maybe you're already doing it. Maybe you're drawing pictures. I don't know. So this ends up being 3.7, and this is a kind of about sort of thing as far as feet to yards kind of thing. Now, pizza paradox being in effect, you cannot buy 3.7 cubic yards of cement. You would need to buy how many?
4 cubic yards.
4 cubic yards.
I gotta remember that the pizza paradox applies.
well, they don't actually say it in the problem. You just end up looking over at the book and it tells you there.
That's common sense. You can buy it.
Yeah, but I mean, they didn't say it, so it's not that intuitive. Yeah.
I have 2 questions.
Okay.
One of them, this is clarification sort of a thingy, but we use, like, after the 100 feet cubed, like, after the unit multiplier there, we do the 1 yard over 3 feet because it says cubic yards, right?
Right. We've basically decomposed this. Presumably because the 27 feet might not have been totally obvious from the outset as a unit multiplier. So yeah, I mean, really, you ultimately could have. You could have just looked at it and gone, okay, so then cubic feet, and then 1, and then we could just say 1 cubic yard would have to be equal to 27 cubic feet. I mean, you could have just puzzled that out yourself and then gone, okay, well, cubic feet, and then gone, okay, well, I can cancel the cubic feet, right, and then go straight to.
Can you do that on a test?
It depends. If it says use multiple unit multipliers, then you would need to do the whole thing out. If it doesn't tell you you have to use multiple unit multipliers, then do it any way you want, as far as I'm concerned.
This is way more efficient.
Lovely. Yeah, much more efficient, yes. But also, we can see what we're doing with the actual math. Room 16. Okie dokie. Hey, Adrian. You've been paged. I'll put the video up later if you want to watch the rest of it. Said you were supposed to pack up. Anyway, so you can watch the rest of the lesson later on the YouTube channel.
I have 1 more question.
Okay, because it would be great if we could move forward.
Then never mind.
Okay, yeah. At this point,
They should be calling you to send brother down.
they did.
Okay.
Okay. All right, Tina. Approach the traffic light.
Hey, she doesn't have a license yet.
Oh, you're going to driving jail for that.
no.
That's actually, you're just going to jail for that.
yeah.
Okay, anyway, as Tina, juvenile jail, I guess. Okay, juvenile detention. Anyway, as Tina illegally approaches the traffic light, she slowed to 36 kilometers per hour. So, convert 36 kilometers per hour to meters per minute. So, there's a couple things going on here. So, ultimately, what we're trying to do here is we're trying to convert kilometers per hour to meters per minute. So that's our goal, right? And so our 2 unit multipliers are to convert kilometers to meters and also to convert oops, I keep messing up my H's. Hours. Okay, bye. See you tomorrow. Hours to minutes. So we're going to need to set up 2 unit multipliers, 1 for each of these guys. So we start out with our 36 kilometers per 1 hour. And then our next thing we're going to want to do is convert kilometers to meters. So what are we trying to get rid of? We're trying to get rid of the kilometers. So we're going to put those on the bottom so that they will cross cancel on kilometer. And then there are 1,000, meters per 1 kilometer. And then our next thing is we're going to want to convert hours to minutes. Which one am I trying to get rid of? Yes, the hours. So in this case, I want to put the hours on top. So that will cross cancel. So like if you're wondering like how do I know which one to put on top and which one to put on bottom, is what are you trying to get rid of? And so since this is on the bottom, I want to put this one on the top so that they will cancel each other out. Yeah, which one are you trying to get rid of? I'm going to want to have minutes. Okay, so once I've got that set up, I can begin my cross-canceling goodness.
So we'll end with meters per minute?
Yeah, so we want to end up with meters per minute, and so we can cross-cancel our kilometers. We can cross-cancel our hours. And then that just leaves us with 36 times 1,000. 36,000. And 1 times 1 is 1.
Oh, I know the answer.
Times 1, and 1 times 60 is 60. In this case, our unit that's left over is minutes. Oops, sorry, and meters was left over. So we'll put that on there. So 60 minutes. And then at that point, you could say, okay, well, I can get rid of these 2 zeros, right? So that gets me to 3,600 divided by 6, which is, well, 36 divided by 6 with a couple zeros. So 600 meters per minute is what I end up with.
Wait, I have a question.
Uh-huh.
Are we going to be doing gymnastics today?
Do not ask me that question right now. All right. So how are we feeling? Give me 1, 2, or 3. Okay, I mean, I will totally take a 2 right now and call it a win.
That would say
All right.
5 minus 1.
Okay. I'll take 2.5. Okay, I'll take 2.5. I'll take 2 and a little bitty more. Okay, I'll take 2s right now. I'll totally take 2s right now.
I have a 2.5. I'll take 2.
Okay. All right. This is gonna get weirder, but also. Well, also, I think this is one that was sort of meant to be done with a calculator. Yeah, it says so. Or at least, yeah, in the book they sort of describe. So we're not going to worry too much about the actual computation of it. I'm not going to like do out all the math, but Claude's car, unfortunately named, averages 12 kilometers per liter of fuel. Claude's car averages about how many miles per gallon? So we can see here that we are converting kilometers per liter to miles per gallon, and so and then I've handily put the basic metric conversion to imperial over there. Yeah, I go. Anyway, so we're starting out with 12 kilometers for every 1 liter, and over here we're going to want to have miles per gallon. In fact, I think I'm gonna lower this down a little bit to make sure I've got room. Did you have a question?
equals 1 gallon?
Roughly 3.781 liters is equivalent to 1 gallon. Yeah, as it says right here. Okay, so that's 12 kilometers for 1 liter. If you can start to figure this out ahead of me, well, actually, there's a bit of computation here that's a little tricky. So our first unit multiplier I'm going to do is miles, converting kilometers to miles. And so since my kilometers is up here, I'm going to put my 1 kilometer down here. And then put my 62 hundredths of a mile on top. And then my second conversion will be liters to gallons. And so since my liters are down here, I'm going to put my liters up here. And the book decides to just stop there, which makes perfect sense. I mean, don't need to be that perfect.
But once you agree with the
I mean, someone was asking, what if we just round out to 4? I would say that's maybe not perfect enough because, you know, you might be trying to compute whether you have enough gas to get somewhere, and that much of a rounding might throw off your results and get you stuck somewhere.
On the side of the road.
Mm-hmm.
With 10 people trying to help you out.
Yeah. Okay. So once we've gotten to this, we can do our cross-canceling goodness. And get rid of our liters. Get rid of our kilometers. And so then that can get us to a more elegant equation. Yeah. So I'm just copying the answer down from the book. I mean, I could bust out the calculator, but I mean, it's right here. It's all right. And so we can end up with this as a thing on top, and we can end up with, well, 1 times 1 times 1 is 1, and everything has been eliminated except for gallons. And spoilers, if you did all this math out, you would end up with...
I stopped at that point because I was using
Yeah, no, it's okay. We're just trying to get some across. Choose 1. Oh, very nice. Okay, good for you. I appreciate you doing that. So that gets us to where we could say 28 miles per gallon. And that's our lesson.